Hey friends,
Welcome to Outlaw-In-Logic. Thank you for shining your light here. In this episode, as promised in our opening page, you and Outlaw-In-Logic will investigate together why the physical theory relativity must earn itself, the above self-refuted equation. To find the answer, you will be surprised to find that it only requires simple algebra knowledge to go directly to the heart of the problem. Relativity, a brief term for the special theory of relativity, is published in 1905 in a German physics journal. It fundamentally starts its theoretical reasoning with the above set of two equations. These two equations only focus on comparing clock readings between two moving systems. The spatial coordinates in equation 2 thus affect no calculation if omitted. The omission will simplify equation 2 into 2-s. It is easy to tell that equation 1 and 2-s are mirroring each other in structure. Now, we can rearrange equation 1 into equation 3. In the same manner, the equation mirroring certainly also allows us to rearrange equation 2-s into 2-r. Now, let us focus on comparing equation 3 and 2-r. Each quantity in these equations corresponds to a specific time instant. All instants in equation 3 are recorded by clocks that are at rest with one moving frame. All instants in equation 2-r are recorded by clocks at rest with another moving frame. Relativity believes that each group of clocks has a different advancing rate in telling time from the other group. Subsequently, the time records are different between these two equations. It is using the format presented in equation 3 and 2-r that relativity tells people how each of these time readings being correspondingly simultaneous with the other one across the equations. Now, between those time readings taken from equation 2-r, we can fill in between them the operational signs in the same way as they appear in equation 3 and 2-r. This procedure is completely natural because equation 3 and 2-r mirror each other. Consequently, we now have equation 4. Equal term cancellation naturally occurs within equation 4. After term cancellation, what is left is only a questionable equation, which is self-refuted for all non-zero value of v. The appearance of this questionable equation is strong evidence that relativity starts its argument with an unreliable equation set. As an unprecedentedly influential theory, relativity certainly does not stop here with surprise. In the 1905 paper, immediately following equation 2, relativity continues with the above two equations, 5a and 5b. Equation 5a is obtained by directly differentiating 2 with respect to the time element t. However, in equation 2, symbol t only serves as a referential constant, not a variable. Equation 2 lists 3 readings of time reading. None of them suggests any change of t. What shows change is the part added to t, but not t itself, staying as a constant the entire time. T must make the derivative delta t taken on it result in 0. Therefore, equation 5a must mathematically collapse, because two of its denominators, are occupied by day t, which must be 0. The collapse of equation 5a must collapse equation 5b as well, because equation 5b emerges as the result of term rearrangement after the calculus operation is completed on 5a. Relativity further relies on equation 5b as a pivotal equation, following which calculation brings out many physical conclusions beyond imagination. Given that equation 5b is a product of fallacious performance on calculus, how much confidence should we have in these conclusions? In addition to all these, equation 2 is even found contradicting relativity's own arithmetic method in calculating light's movement. If equation 2 had faithfully followed those methods, every denominator must have its operational sign replaced with an opposite one. Subsequently, in place of equation 2, relativity should have equation 2 revised. Inevitably, then, what Relativity's 1905 paper could conclude must have been something else, other than those that we have been told. Here is the arithmetic method in our concern, but equation 2 contradicts it. It is quoted from the 1905 paper. As a matter of fact, this method is emphasized in the 1905 paper, even before equation 2 is introduced in the same paper. The method states that the time needed for a light ray to overcome a distance and catch up a moving point is to be calculated with equation A, which has a minus sign in its denominator. If we repeat the movement, we will see that, to adjust to equation A, the ray and the rod are moving in the same direction. Equation A is concluded by a ground observer not moving with the rod. Next, the time needed for a light ray to separate itself from a moving point by a distance is to be calculated with equation B, which has a plus sign in its denominator. Obviously, equation B is applied when the ray and the rod are moving in opposite directions. For the convenience of future reference, we will make note to each of these two equations for their application purpose. Now, with all these arithmetic details stressed with equation A and B, it is time for us to inspect how equation 2 has mistakenly applied such methods to its own establishment. Relativity constructs its equation 1 and 2 based on two 3D systems that are moving at speed v with respect to each other. However, relativity uses only the x-axis from one system and the quasi-axis from another system to study the behaviors of some running clocks and moving rods. For easier description, we will name the quasi-axis as a train, and the x-axis the train station. According to the 1905 paper, a mirror is set at point x prime on the station. To begin, the train moves at velocity v in the direction of increasing x, and a light ray also flies toward the mirror, starting from x0. Regarding the train as his own ground, the train observer sees the ray flies away from him, whereas the mirror is approaching him. Therefore, he can claim that the ray and the mirror are moving in opposite directions. After the ray is reflected, the observer sees both the ray and the mirror move more and more toward the negative direction of the train, or equivalently, the quasi-axis. So, during the ray's reflection trip, the train observer can claim that the ray and the station both move in the same direction. However, equation 2 in relativity's initial set shows apparent disagreement on what equation A and B would guide. The term in the yellow box expresses the time needed for the emitted ray to complete a distance of x prime. During this emission trip, the train observer sees the ray and the mirror move in opposite direction. Therefore, this term should have a plus sign in its denominator, as what equation B would only approve. The term in the oval box expresses the time needed for the reflected ray to complete a distance of x prime. During this reflection trip of the ray, the train observer sees the ray and the mirror move in the same direction. Therefore, this term should have a minus sign in its denominator, as what equation A would only approve. Now, evidence has been plenty to make us believe that equation 2 is mathematically unreasonable and unreliable. What supports the appearance of equation 2 is the unrealistic belief called the second postulate. Fundamentally, according to this postulate, the speed of light in any inertial frame is measured the same, regardless of how fast this frame is moving. We previously demonstrated that due to the mirroring action, equation 1 and 2 can be rearranged as equation 3 and 2 are. With these two equations, relativity believes that if two different moving frames can simultaneously share the same emission point and reflection point, the second postulate will enable the following phenomenon to appear. The phenomenon it pursues is that the reflected ray will return to the emission point that both frames must simultaneously share once again. Let's see how the second postulate works with our system of train and station. Upon the time the ray is emitted, the emission point is certainly shared simultaneously by x0 on the station and the train observer. However, in the reflection trip, because of the movement between the train and the station, the ray must meet the train observer before it meets point x0. The second postulate cannot make the observer and point x0 simultaneously share the ray at the same location. Inevitably, therefore, the x prime value in the breaking term of equation 2 is a falsely assumed value. In summary, equation 2 is a problematic equation. It is self-refuted. It confuses itself with frame moving direction. It forces assumption of simultaneity for calculation. It certainly surprises us even more why ERA at entry level of calculus operation can find business to do with this equation. In the next episode, Outlaw-In-Logic will present a video to explain the idea behind the Michelson-Morley experiment is self-refuted. Along with us on this new journey. Stick around until the end to learn why this experiment and relativity resulted in ether being unfairly cast aside for over a century. Please subscribe to us so that you will know the moment a new episode drops. Every video will be worth your time, clear, honest, and thought-provoking. Thank you for watching. Hope to see you and read your comments soon at Outlaw-In-Logic.